the discussion we had in the last class. I made the change. Number of customer is denoted by Y and the distance is denoted by X. The number of customers who are visiting in the shopping center in hundreds, 10 days survey. And these customers are having the distance how much from their residence. So Y is a function of X. So we have plotted the scatter diagram. We have computed correlation coefficient. We have talked on the graph, etc. I am revising now once again. In my R package, I have typed the data. As usual, I have here X values and Y values. So the first work was scatter diagram. So I said plot. Yes.
Sir, sorry to interrupt you. Are you sharing this worksheet with Swati ma'am?
No, only record. That is, everything will be there in the record. We are recording the session means everything will be available.
Okay, sir. Okay.
So plot graph Y curly X. So when I do the data plotting, let us see whether I can get the graph. I got the graph. I got the graph. And on the graph, the data shows a decreasing behavior. If I plot arithmetic mean of X and Y if I plot, I get both the arithmetic mean on the graph. Both the vertical line will be mean of X. The horizontal line will be mean of y. Left side of the red line. The points are more than that of the right side. This says smaller the distance, more customers will be arriving in the shopping center. Right side, we have very less points. And the right side of the red line means more the distance of the customers from the shopping center. And this speaks as the variables are negatively correlated. Correlation means tendency of the dependent variable towards independent variable. Tendency in this data is as x increases, y decreases. So we call negative correlation.
Hello.
Yes.
Sir, can you repeat it again? I was disconnected for a while.
You have to be well attentive. On the graph, the red line is arithmetic mean of x data. The left side of the red line, the distance is smaller and more visitors in the shopping center. See the graph? And the right side, they are very less. Which means there is a tendency of y to decrease as x increases. Such a dependency we call negative correlation. Opposite direction. Changes of the variables are in opposite direction. As x increases, y decreases. Then we computed a measure R. Covariance between x, y upon standard deviation of x, standard deviation of y. Correlation coefficient is a measure that talks about the strength of dependency.
Sir,
Yeah.
could you please zoom in a little the PPT?
What is that?
Sir, could you please zoom in a little? Could you please zoom the PPT a little? Yes, yes.
So R is covariance upon product of standard deviations. So when we say R is correlation coefficient. R is correlation coefficient. It is a measure to speak about dependency among the variables. How good the dependency and how poor is the dependency. And the correlation coefficient for any data lies between -1 to +1. Let us see how much is the answer I am getting here. Yes. -0.8682659. This means sign tells about the negative correlation and the number tells about the degree of correlation, and 0.868 is very near to +1, or -0.868 is very near to -1. Correlation coefficient is always between -1 to +1. The computational formula is covariance upon product of standard deviations. It is product of standard deviation. So the graph tells about the tendency. R tells about the dependency of variables.
So, I have a quick question here. Which is the dependent variable and which is the independent variable here?
You were present in the last class?
Yes, sir, I was present, but I'm having this confusion. There are two variables. One is distance, one is the number of consumers. So, sir,
Now, number of customers coming to the shopping center. So, who depends on whom? You decide logically.
So, sir, number of customers depends on the distance. So, number of customers should be the dependent variable and distance should be the independent variable.
Yes.
So, distance should be denoted by y. Because y is...
In the question paper, it is given. Hai na?
Yes, sir.
I made it a change. I made a change last day. Number of customers visiting the shopping center is Y, and other will be X as a standard notation throughout the session.
Yes, sir. I get that. But sir, generally, distance is supposed to be denoted by Y because Y is dependent.
No. Customers coming to the shopping center is more if their residence is nearby.
Yes, sir. Correct.
So the number of customers will be depending on the distance they are coming from.
Absolutely, sir.
So Y will be dependent on X.
So, sir, the dependent variable is denoted by Y.
Yes.
Okay.
Throughout the session, this is the standard notation.
Okay, sir. Got it.
So the value which we have here is a negative number with a value very close to 1. So it shows there is a tendency to decrease. So we say a regression of Y on X. That is Y equal to P0 plus P1 multiplied by X plus E. This is the notation we have used last day. Who can explain me the meaning of the equation? Today our work is compute B0, compute B1 and speak about E.
So, sir,
Yes,
in this equation, B0 is intercept, like last class you discussed it.
yes,
And B1 is the slope of, and E is the residual, that is also
very
the
good.
deviation.
Yes. What is the meaning of E? Who is the answer giving?
Mohit, sir.
Very good, very good. What is E means?
Sir, it's simply
E means the
residual.
residual thing, but what X can't explain the.
Yes, sir.
What is the
Sorry,
meaning
sir.
of E?
So that is the true value minus the data value.
Correct.
The
Perfect.
deviation of data from the line.
From the line.
Very good. Very good. Very, very good. So we have now the regression. So today the work will be computational work. Today we are going to do the entire thing finding B0, B1. So the B1 value is covariance numerator is covariance and the denominator is variance of X. B0 will be mean of Y minus B1 multiplied by mean of X. So B1 and B0 you will get. This is computational step. Attentive. At the end of the class today, I will be explaining the mathematics behind the formula, from where we got the formula. Slope of the line will be covariance upon variance of X. Intercept will be mean of Y minus P1 into mean of X. Let us see the answer. I got it. So the value which I got, B1 will be negative 0.2945323 and B0 will be 12.43932. So the estimated line of the dependency, comma, mathematically is by estimate is equal to B0 value 43932 plus it is slope. Slope is negative in bracket minus 0.2945323 multiplied by X. This is the line. So if you put X, you will get estimated value. So when you get the regression line, that is a statistical model for the real data in your survey. It is the regression equation. It is the linear regression equation of dependent variable on independent variable. The slope is negative because correlation is negative. Both correlation and slope are negative because the graph has a downward tendency. Both correlation and regression coefficient has negative sign because as x increases, y decreases. So let us find out them. Let us find out them. See them? I will plot them also. I will plot them. When I see the graph, see it is a straight line. This is the line passing through the scatter diagram.
So did you use that curly sign between?
Yes.
Okay, thank you.
The estimated value is on y-axis and x is x-axis and the fitted line is on the graph. Original data is not a graph. But,
Sir, could you increase the font size of just the editor?
Yes, sir,
for
same
the
one.
moment, let it be. I will do afterwards. There is a problem in my R.
Okay, sorry, sir.
So when I fit the model, I will be having a straight line. So when I have these points, now it is a matter of finding the error. So E will be actual Y minus Y estimate. So when I speak about the computation of E, there can be negative E as well as positive E. What is the meaning of negative E? Anyone?
That the points lie below the
fit line.
Below the
points
line.
lie below the fitted line.
Correct. And positive will be
Above the
The
fitted.
points lie
Above.
above the
Do
regression
you
line.
have any zero value in the answer? Is it is zero in our data answer?
In this data set, no, sir.
No, which means all the points are away from the line, either above or
Below.
below. So can I find the arithmetic mean of E?
Yes, sir.
No, we cannot find the arithmetic mean of E. Why? If I add up them, actual deviation will reduce.
Will be
Am I right?
yes, the actual deviation would tend towards zero.
Right. Actual deviation will reduce. because of positive and negative sign. Therefore, how to compute now E for the model?
Squared.
So what we have to do is, it is this E also called as residual. It is also called as standard error. It is also called as standard error. So I denote it by SE. The standard error is computed mathematically to avoid the disadvantage of addition. We take the sum of P square divided by 8. The denominator is always n minus 2. I will tell the mathematics at the end. Now I'm telling only computation. So how much is the value? Square root, because I'm squaring it. So square root of see, error is positive and negative. I cannot add up this to find the average error. If I add up this, I will get the deviation ineffective.
So what are you dividing by?
N minus 2. Sample size minus 2.
Degrees of freedom.
Yeah. And when I speak about the estimate of error become squaring, adding, divided by n minus 2 and square root. Let us see how much will be it. Oh, I have not saved keyboard. $1.363145. This is what we got. B0 we got, B1 we got, error term also we got. Error term also we got. Any question? Anybody? Now I'm going to higher level. A hypothetical line. Hypothetical line is a line that shows tendency of the dependent variable on independent variable. So in our original graph, there is a downward tendency. That is, in mathematics, we say straight line. But all the points on the graph, not a line. All the points on the graph is not a line. So which is my line? B0, B1 plus E. What are they? Line plus deviation. That is actual data. How much deviation of the data from the line is E? Find out them. Yes, by method of least squares. Mathematically, we say all the formulae so far I have typed is derived through method of least squares. So by the method, I got the line, I got the standard error. Standard error is the value for E. Because E itself I cannot assume. values because negative, positive, so average not possible. So mathematically, we have derived an average number as standard error. Square root of square of the deviation and addition divided by n minus 2. Yes.
Sir, is there a direct formula to run the regression instead of doing it like
Yes,
this?
we have. We have.
Okay.
I will show after completion. Within a minute, you can get all.
Okay, fine. Thank you.
Within a second, you can get all. So this is what I expected to revise whatever we have stopped last time. I repeat once again. I have the data, and throughout the class I denote the data y dependent variable, x independent variable. I plot the graph. I plotted the arithmetic mean and comment. The red line will be a straight vertical line denoted by mean of horizontal axis. That is mean of x. And the horizontal axis will be the mean of y. Study the clustering of the points. Below or left side of the red line, there are plenty points. They show a negative correlation because as x increases, points of y decreases. That is denoted by the regression equation with the constant numbers b1 and b0. The degree of correlation is shown by correlation coefficient. So how to find B0, B1? I have given the formula. The formula is derived by the method called method of least squares. Method of least squares. Therefore, estimated line become minus 12.43932 minus slope into x, by which I can plot this line also on the graph. You saw a straight line. And the deviation is therefore y minus yst, and they are positive as well as negative. So average E you cannot find out because when you add up positive, negative will reduce the sum. So the method of least square says square them, add them, divided by n minus 2. So we got what is called standard error, residual number. This is the work I have done. Yes,
sir. So how can we fit this regression line in the original scatter plot?
Yes. Such work I will be showing afterwards. Complete topic I will complete within a minute, not now. Now you are learning. So your objective is just to go for learning computational work.
Sir, I have a question.
Yes.
Sir, I'm sorry to ask this again, but why have we assigned the number of customers as an independent variable?
Where do you stay?
I'm in Pune, sir.
Pune. Which location?
Wanavadi, sir.
Vaishali restaurant is a popular restaurant in FC Road. Can you come there for breakfast every day?
No, sir.
But if you are staying on Ferguson Road, can you come to Vaishali restaurant?
Yes, sir.
Why? No first. Why yes next?
Because the distance is more from my place. I cannot come.
So the visiting Vaishali restaurant depends on distance that the customers are staying by.
Exactly, sir. So in this case, the distance should be the independent variable, no?
Yes, that's what I have taken.
But so it is my understanding that we have taken number of customers as an independent variable.
I never took. You not listening properly. I have not taken. Y will be my dependent variable. See the equation, y will be left side. And the right side is my x. So y is a function of x. You misunderstood. You have misunderstood. You are not attentive. My y is a dependent variable. Customers to the left side depends on the distance coming. See? Y is a function of x. X is distance. Y will be the number of customers. So this computational work I have shown to you.
Sir, I have a question.
Yes.
Sir, like you taught us the sequence function when we have a lot of data and it is not easy to put in the R editor.
Yes.
Then we use sequence function.
Yes.
But then what if we have a lot of data and it is not uniformly increasing or decreasing?
Yes.
Then what do we do?
You will be having the file. Na? Read the file.
Okay.
Read the file. I have shown last time.
Yes, sir. Yes, sir.
So
Now, yes.
I am also getting confused at one point. Like when we drew x and y points, we got a scatter plot.
Yes.
And then when we regressed that equation, we got a linear line, straight line.
Yes.
So how is it so? Earlier we were getting a scatter plot.
Scatter plot will be different. I have fitted the line on a different graph. I fitted the straight line on a different graph. What is the question?
That when we plotted x and y, so we were not getting a straight line. The points were scattered.
Yeah, x and y will not be having the straight line. Now, that is a real data. I am plotting here y estimate and x. Second graph.
Okay.
The second graph will be y estimate and x. That is a straight line. That is a straight line towards right bottom. And error of the earlier data from this graph is 1.363 on an average. Any other question? Any other question?
And sir, what is this GUI preference? So your voice is breaking, I guess.
Chat, you type it and show me. Yes. Who was asking that? Type it and show me.
I was asking what is this, why we use this GUI preference?
See you.
Above it's written as GUI. You selected GUI.
GUI will be for changing the format in edit. Now, I will be sharing the question paper once again with you. And see the work that I have done later on. This is what the data I have worked out. Every one of you has to do the work on the second question. Then I will show you what is happening. So start the work on second question. Weight depends on X. Y will be the weight of the individual. X will be the height of the individual. All of you start working on it. 15 minutes I will give. And then I will show the answer and see what is happening in the data. Start. All of you have to start it now.
Run a regression on question 2 and 3 or only 2?
Only two. Y on X. Everybody should work.
Sir, could you please keep the question paper on the screen?
Okay, I will do.
Thank you, sir. Yes. Question 2. Everybody should work.
Sir,
Yes.
do I need to plot and calculate the mean as well, or just the B0, B1 and
Everything. Arithmetic mean, you have to see the comment and everything you have to do.
Okay, sir.
Everyone has to work. I am asking question. After I satisfy with your answer, I will show you the change.
So should we share the value?
Yeah.
I got B naught as minus 107.13913.
Okay.
And B1 as 1.02714.
Okay. Let me verify. Let others also complete. Then I will show my answer.
I have the same value.
Yes, sir. That's sir. I also got the same value.
Sir, I'm also getting the same.
Very good. Okay. You my answer now. I will be sharing my answer. So here the weight depends on height of the individual. Weight of the individual depends on, weight is an independent variable and X is independent variable W and height is given. So is it the graph everybody got?
Yes, sir.
Yes, sir.
Yes. Now here the points are opposite to the first question. The first quadrant, no points. Second quadrant, many points. Third quadrant, many points. Fourth quadrant, no points. So the points are showing an increasing trend. The points are showing an increasing trend. Which means the graph will be having a positive correlation. The graph that we are having here is a positive correlation with 0.9442254. Is it your answer?
Yes, sir.
Yes. So it is a highly positively correlated. The changes are on the same direction. As X increases, Y also increase. As X increases, Y also increases. Now the line. The line of dependency here is with a positive slope. The straight line will be left bottom to right top. The intercept will be minus 107.1391. And your B1 will be 1.021739. So your equation will change. So your intercept will be negative 107.1391 plus the slope will be 1.021739 x. Minus 107.1391 plus 1.021739 into x. So how much is the y estimate? Let us see. Why there is an error it shows? It is correct.
I think so. Y के बाद equal to sign होगा.
नहीं equal to नहीं होगा.
Because I have done
1.021739 multiplied by x. X is correct. Symbol is x.
So you haven't run the code for YEST. That's why you only run the name.
Hey, I have coded y. Let's
yeah, but you didn't run it. You only run the name.
Sir, try
Only the name. There. No, sir. Run the entire equation with the code. Run both of them. No,
Okay.
no, sir.
That's what I have done here.
Just run both the lines like YST equal to that thing like 17.1391. Run that line together with YEST.
Yes, that is what I'm trying to see. Got it. Yeah, correct. Both. Yeah. So your estimate is this. Plot the graph. See the straight line or not. So when you plot the straight line, you will be finding it is a straight line with some error. And the error is computed and we got finally the standard error.
We got a nearly perfect correlation.
Perfect. The standard error will be 2.416767.
Yes, sir.
But all the question number 1 and 2, I can show directly within 3 statements. No need of all this work. That is the next. That is what I'm expecting you to do later. I will tell you. See now. I will be giving the title in my module correlation, comma, regression using LM function. What is LM? LM means linear model. LM means linear model. So I say model LM by curly X. Finished. And I say, give me the summary. See now what is going to happen. Only this much complete answer you are going to get.
So what is this LM function?
LM means linear model function. LM.
Okay, sir.
Linear model, dependent variable on independent variable. See the answer. Complete answer is ready. Residual, minimum value to maximum value. That means each error, positive as well as negative. Minimum is minus 3.05, maximum is 4.7696, and the center is minus 0.6217. Next. This is B0 and the Nietzsche number will be B1, that is intercept and X. With standard error 2.417. Then what are the other numbers? Yes. They are the numbers derived through probability to test validity of your analysis. They are the numbers which are derived through probabilities to speak about whether your sample data gives a good model or a poor model. I have to deal with this. I have to explain you completely this, but not now. After probability. When I start testing of hypothesis, that is last part of the syllabus, I will be repeating correlation regression by LM function to know whether your analysis is a good analysis or a poor analysis.
Sir.
Yes.
Like when we use this summary function, so in this multiple R squared, it is like, giving basically it's giving R squared value and adjusted R squared value.
Yes.
But here we have a single variable that is putting to the model. So why these values are different?
Let it be. I will explain you. It is called coefficient of determination.
Okay, sir.
That is different. R square is different.
Sir, basically adjusted R square and R square, the key difference is like, adjusted R square takes into consideration like how significant a variable is in contributing to our model, and R square all the parameters of the model and gives us the value, like what is the right. Perfect. But in this case, we only have a single variable, which is like, we are trying.
Doesn't matter whether it is a simple regression or multiple regression. R square tells about the coefficient of determination, contribution of independent variable on dependent variable. Wait now, wait. I will be coming to such explanation when I do test of hypothesis.
Okay, sir.
Now everybody let come by good platform first. Okay, so you saw now here stepwise computation as well as function. For examination, suppose if I give a data and say compute the regression model and standard error, verify the answer by LM function. So both the ways you have to work.
Okay, sir.
If I tell you read a data, for example, I have plenty files in my R. I will say read the data from the file and then compute regression and standard error and test the validity. Then you have to do testing of hypothesis. So many things can be asked in your final examination.
So, sir, it means when we enter just X and Y data and this LM function, we will get this complete coding.
Correct. Yes. By means of the linear model function, you will get the answer up to date. And this is the one you have to comment on: reliability of your forecasting, prediction of your value.
So, but what's the meaning of this? How we got
What is the meaning of? What is the meaning of?
This LM function? You wrote this model in the
Linear model. Linear model. Because we are dealing with only linear graphs. Whatever we have done in question 1 and 2, I am doing that by means of a function called LM. No botheration of remembering covariance, no botheration of remembering the graph, no botheration of remembering the variance, everything available. But what are the other parameters in the output? That also we have to learn. So today we have just computed the parameters. We never spoke because data is only sample data. Who can believe whether the sample is a correct sample or incorrect sample? Somebody can cook the data also. So when you are taking a sample, you will take methodologically, then we can do much work. So the real data, mathematically you are converting, and then we are talking about the validity using LM function. Any other question? No, ask and get it clear. Very few are asking the questions.
Sir.
Yes.
In my editor function, editor box, in this, when I applied this LM function,
yes,
it is reading data from my second question.
Yes.
And when I am applying this LM function in my first question, the same editor page, then again it's taking the second.
Because you are using the same variable notation, maybe.
Sir, okay.
Change the variable because you are working on the same file, na?
Yes, sir.
Change the variable. Height you denote by H, weight you denote by W, and then work. Okay. Any other question? Okay. So we saw here many of the things. All this work we called method of least squares. I will tell you the theory behind the formulae. It is called method of least squares. Method of least squares. And what is method of least squares? It tells, okay. Can anybody tell me? Suppose in a real data, I plot attentive. Suppose I plotted the scatter diagram for the real data. And I found error term 0. What does it mean?
All points lie on the regression line.
Perfect.
X and Y is same. Both X and Y is same.
I equal to Y estimated.
Yes, perfect. which means if I say the real data become a straight line, means real experiment in the nature become a mathematical model.
No, sir.
And if the mathematical model has a smaller error, means forecasting future will be 100% true.
No, sir.
Not followed, yes. Suppose if I plot a scattered diagram on a data and error is 0. So the scattered diagram will be a straight line.
Yes, sir.
So when the scattered diagram is a straight line, means the real phenomena, your survey result become a mathematical equation.
It becomes identity.
Isn't it?
Yes, sir.
And if it is a mathematical equation, if I use that for future value will be 100% true without error.
Yes, sir.
Yes.
Yes, sir.
How many of you follow?
But it's hypothetical. It's very...
No. I add if my real data, suppose time spent by the student for preparing the test and their marks are the two variable I plotted on a scatter diagram. So the marks depend on the time spent by the student. It shows a perfect straight line to the right top. That means it is behaving like the student's data, a straight line equation. That means if a student studied 10 hours, how much he can get it estimate, and that estimate will be his true number.
I still didn't understand what you're trying to say. Sorry,
goodness. Sir. Madam, what is error?
Error
What
is the
is the
difference. The difference between the actual value and the estimated value.
That is 0.
Okay, but I'm saying in real life it is difficult to get a 0 value.
That is a different thing.
Yeah.
That is a different thing. So I wanted to say smaller the standard error, better will be the model.
Yes.
Can you believe now?
Yes, sir. Sorry.
So definitely in real problem, you never get E equal to 0. 100% true. But mathematics says minimize the error to search a model.
Yes, sir.
That is called method of least squares. Method of least squares minimize the error and gives you a better model, better equation.
Yes, sir.
Is that clear now?
Yes, sir.
So it says pi minus y est raised to 2 should that is y minus b naught minus b1 multiplied by x raised to 2 is minimum.
Yes, sir.
Then b naught equal to how much? b1 equal to how much?
So we can take the derivative of this.
Correct. And the answer for how much will be, you have to differentiate your quantity. Suppose if I denote this as pi e square or some function. Suppose if I denote this as my function and differentiate the function with respect to beta naught equal to 0, differentiate the function with respect to beta 1 equal to 0. Solving this, you will get all the formulae that we have computed.
Yes, sir.
This is called method of least squares. Rahul Giri,
Yes, sir.
do you follow
Yes, sir.
clearly?
Yes, sir.
Very well.
Yes, sir.
Okay. Okay. Himani Gaba,
Yes, sir.
you understood so far whatever we have done?
Not completely, sir, but yeah, trying to understand it.
But immediately you have to repeat it today itself. And next week, I am giving one more chance for revision of 1, 2, 3. At that time, ask and get to clear the doubt.
Okay, sir, sure, sir.
Yes. Sayoni Lahari,
Yes, sir.
do you follow?
Yes, sir. I've been following.
Very good. Very good. Ayushi Rohatgi?
Yes, sir. I'm following.
Yes. Bharat,
Yes, sir.
how do you find the class today so far?
Interesting, sir.
No problem.
No, sir.
Okay. Okay. So this is what the work I have done today. But not over. Somebody asked me, sir, if the data is huge, what to do?
We take samples for the data.
The sample data itself is a huge data, then what to do? Can anybody give me the answer?
Run the file.
Run the file. So that also I will show now. Data, open close parenthesis. And if I say data, open close parenthesis, and execute it, I will get the list of the data. I will get list of the data. And one of the data I will be taking as trees. One of the data I will be taking as the trees. So my data become reading from trees file. I want to know what are the things in the file trees. I will execute. So the tree file consists of girth, height, and volume. Volume is a function of girth and height. So here two variables contribute on dependent variable V. This is multiple regression. At present, I am not going to do. I will be doing only simple regression. This is multiple regression. Say for example, volume is dependent on the girth as well as the height. So I say one of them will be my variable. I will be taking girth as another variable. I can do every work as I did before. I can plot it and verify. I can plot it and verify. See the graph. I will get a graph. A very good graph with a lot of points towards right top. This is positive correlation. This also has a linear model. There is a standard error. So everything is repeated now. Everything is repeated. If I show the height, and if I plot volume against height, I will get another graph.
Sir, kindly check your spelling.
HEI. Height. Sorry. See, but this correlation is small. So which variable contribute more in volume? Anybody? Is it girth or height?
The girth, sir.
It contributes more.
Which variable contribute more in volume?
Girth.
It is girth. Because height has a scatterness more from volume compared to girth. So higher will be the contribution of girth in the volume. Suppose pi equal to marks, x1 equal to faculty, x2 equal to percentage attendance, why denote the marks? X1 denote the faculty who explains you the subject, and your percentage attendance are 3 variable. So y is a function of So I want to know, or the student wants to know, how much effect of the faculty in his marks? How much is his percentage attendance in the mark? You have to run correlation regression. Take another example, y. Yield of the crop in kilogram per plot. X1 is rain received per plot. X2 fertilizer applied per plot. X3 equal to climate condition. So now the y will be a function of 3 variables. You want to know the effect of each of them in your yield. Answer is correlation regression. But every time we cannot go for individual computation, functions will give you the complete output. And to know the effect of each variable in your y, you have to do correlation regression properly. So every field, when there is a dependency among the variables, every field, not only in management level or economics, every research area, you are going to have data. Without data, you cannot reach the objective of the research. So every data, if you want to analyze, you have to know properly statistical methods. So correlation regression, I have introduced only computational work. I never said any validity of the analysis. And for the validity of the analysis, you have to know testing of hypotheses. So, only 2 questions we have worked out. Only 2 questions you have worked out. 3, question number 3, you can work. And question number 4 is a repetition of module 1. So 3 and 4 you have to work and prepare and come for the next class on Tuesday. Tuesday will be the last day for revision of module 1 and 2. Afterwards, no revision. Question number 3 is a straightforward question. Question number 4 is not the data given as it is given in a group form, in a frequency distribution form. I have already explained in the question sheet itself the logic behind correlation regression study. So you have to well understand question number 3 and 4.
Sir, I have a question regarding question number 4.
Yes.
In question number 4, you have given the formula for covariance for the group data, right?
Yes.
So in this formula, shouldn't be a f in the numerator, like summation of x minus mean of x into y minus mean of y? Shouldn't this be multiplied by frequency and then divided?
Happy?
Yeah. Thank you, sir.
Thank you. So this way you are able to find everything. To conclude today's session, little more, I will be telling you what is the use of learning correlation regression. Suppose Y denote pail of cold drink in thousands, bottles per day. X denote temperature per day. Sample is of 40 days by X values. A regression says 5 1000 plus or minus 500 bottles to be kept when temperature equal to 30 degrees Celsius. Explain. Nothing I am giving you. I have done an analysis on sale. Number of bottles to be sold and the daily temperature.
Sir, it is basically giving us the confidence interval that that the true value will lie between 4,500 to 5,500.
Yes. This is statistical number. So the answer is 4,500 to 5,500. Any number between 4,500 to 5,500, if he keep in the restaurant, he will not lose the customer. But this is a data from the past business days and is derived by statistics based on sample. But as a businessman, what he does? But the owner anyone? As a businessman, what the owner does for his welfare of the restaurant?
He should keep the number of bottles between this interval, and we can check the significance of numbers by testing it.
No statistics now. He doesn't know statistics. He asked me, sir, you have done the statistical work and giving me the interval. But what shall I do for not to lose the customer?
If I was the businessman, sir, I would store 5,500 of bottles.
Yes. You also depending on statistics then. But if you are the businessman, what else you will do?
Sir, can you please repeat the question?
You see, statistic here, Vaishali restaurant is asking not to lose the customer. Vaishali restaurant is in a limited space. They don't want to lose the customer. So they ask us, sir, tell me in summer, on a day temperature 30 degree, how many bottles to be kept in my restaurant? I gave the answer 4,500 to 5,500. He doesn't follow that. He is a businessman. Based on the number, how much, what he does. This is derived by the statistician.
So he can determine his per day demand and he will want to keep.
That is what per day demand based on only we did the analysis sample data. Dekh lo 40 days ka data. days ka data is my sample data. I have done regression, I have done test of hypothesis, everything, and final answer I gave him. The interval 4,500 to 5,500. But he says, okay, this is number based on sample data, sir. But I am a businessman, not to lose the customer. Tell me, what shall I do?
He'll keep just 5,000 bottles.
Sir, he put refrigerator.
If you put only 5,000, then if a day customer comes at me 5,200, 200 customers के लिए bottles नहीं है. He doesn't
So
want
the
that.
sir, he should take the 5,500 so that he doesn't lose any
Yes,
customer.
that is the number you got from statistics.
Sir, he should look for better storage options.
Correct.
That doesn't restrict him with the temperature.
Correct. If the storing capacity is more than 5,500, he will do storing number more than 5,500. So when the temperature 30 degrees Celsius, definitely he will not be losing the customer. Who gave that answer?
Sir, one more thing.
Sorry, sir.
Take a minute. Who gave that answer?
Sir, Ayushi Gupta.
Okay. Yes, you ask me.
Yes, sir. Sir, now, like shopkeeper can check the future, like for forecasting, temperature forecasting from mobile, and then you can see like temperature would be अगर ज़्यादा होगा तो रख लेगा, नहीं होगा तो रख लेगा.
Even if he keep the number of bottle will be 6,000, remaining will be he can use next day. Or according to 6,000 storage, what is the trend on the day he can understand and he can give order for the next day.
Sir, this
Therefore, what I want to say is correlation regression tells you forecasting for future. Accordingly, you can plan and execute it for getting a better business result. What is the sentence I said? Correlation regression is a topic that tells about forecasting, and the forecasting depends on several other variables. And after forecasting, you can develop strategies to reach the better result. Suppose class test 1, class test 2, class test 3. 100 times I say, don't wait for the better performance. You have to perform better for test 1, 2, 3. A student not take care of, got less marks in test 1. Definitely he will contribute better way to get a good score on test 2 and 3. So the past experience of the phenomena, analyze it, draw valid conclusion, and then decide about what to do in future. Unless you have analysis result verified, you cannot do any planning. That is what the topic correlation regression does. Whether it is simple correlation regression, multiple correlation regression, kuch bhi ho. Every time you are dealing with forecasting, how good is my forecasting? And the answer is work out like this today I shown and do test of hypothesis. So when I will be introducing test of hypothesis, I'm going to start again correlation regression. But there I will be using linear function LM. I will be using LM. Yes. 2 of the students left now. See, total today there was 90 students. Now the number is 88. 2 of them are left. This is what I say.
Sir, sometimes due to connectivity, people get dropped out.
But I am looking the name also here, na?
Yes, sir, I
If the
agree with you.
connectivity is not there, they have to come immediately after connecting it. Can I say my connectivity is not there and keep quiet?
No, sir.
Then
So sometimes between the class
sometimes
also,
nahi. Sometimes nahi. Then why it is not happened till 4:15? Now it is happening. Why?
so for in my connectivity also, I got log out 2 times, so I have entered again.
It all will happen. You have to be there. I'm checking the name also.
Yes.
See, those who left too, they are still not joined back. After giving you so much effort to learn, still you students are not showing interest. Yes, Mehir.
Sir, for today's reading, should we refer statistics for management for additional reading?
Yeah, read it.
Okay,
Read it.
sir, because I'm from non-mathematical background, that is why I need to
you
do
have
it
to read
twice.
it. Now, no excuse of
Yes, sir.
non-mathematics. Everybody has to read. You have to listen the Pat Obi video also and listen what I speak on every session.
Yes, sir.
If you want to develop a good career afterwards, you have to all work on 3 sources: book, video, as well as daily session.
Yes, sir. Sir, I have a question.
Yes, ask the question.
Sir, related to that businessman question.
Yes.
Sir, like if the businessman has this option to get a better storage, like according to the temperature, then why would he at first go to the professional to ask about the regression and all?
Yes. But whether he has to go to the next storage or not, he has to analyze his business data, isn't it?
Yes, sir.
So past data, because Vaishali restaurant doesn't have good storage system, you go and check, very limited space. They keep everything fresh.
Sir, also the initial cost of getting that thing is
That is the reason inventory control is a topic for developing best business strategies.
Yes, sir.
I have given you only one thing: correlation regression. It involves cost, it involves time, it involves transportation, it involves behavior of the customer, which brand they buy, everything comes.
Yeah.
That I can't speak now. That is goes inventory control. So in what happening, in a business, everything is related to each other. You cannot avoid statistics. You cannot avoid operation research. You cannot avoid the packages. Everything comes together to do better analysis and become a good analyst.
Yes, sir.
So you people have to come forward to accept all the things. Initially it is difficult. It is difficult. But once you got the track of working on research, easily you can enjoy the work. That's the reason we are giving you the R package. You see, correlation regression I have computed stepwise. But finally, within 2 statements, we got the entire output, isn't it?
But sir, how do we get this? Abhi to aise aapne bata diya, but there must be something other things also we are supposed to do.
Wait. Session 4 onwards is high level, and test of hypothesis depends on probability. So I have to introduce you what is the meaning of probability and probability distribution. Then only together we can analyze the data.
Yes, sir.
Module 1 and 2, 3 are just computation. No probability word I used. That's the reason next week, Monday and Tuesday, for both the session, I'm completing revision of 1, 2, 3. Afterwards, I never turn back 1, 2, 3. We don't have time.
Sir.
After statistics, we have to go to operation research also.
Okay, sir.
The paper is very lengthy. It is not simple. Okay, so let me ask you questions, Pratik.
Yes, sir.
Do you follow the work I explained right now?
Yes, sir.
Can you explain me?
We started with the question number 1 that we have done in the previous class. And then we plot the graph. Then we find then we find there is a negative correlation.
Yes.
Then we find the R value. Then we find the value of beta 1 and beta 2, beta naught. Then we plot the estimated line.
Yes.
And then we find the residual, standard residual.
Yes.
And then we did the second question.
Okay. What is the main objective of learning correlation regression? That I explained last. Can you tell me what is it?
So we find that there's a negative. I don't understand exactly.
Okay.
I'm trying.
Yes, Sharan.
Yes, sir.
Can you explain me that forecasting example I introduced at the end?
Yes, sir.
Explain.
So using correlation and regression, we can forecast. And actually, what you were explaining the last example was a businessman's plan of action. Using
Yes.
If he asks a statistician that I have this is the temperature, this is the quantity, this is the 40 days data, I have past data of cold drinks which have been sold, then according to statistics, how we can forecast the amount of inventory we should have.
Very good.
According to the sales we are having, and according to the different conditions, that is temperature we took in this example, and cost and demand also can be included later when we do multiple regression.
Very good. Rahul Ghosh.
Yes, sir.
Do you follow the content of today's class?
Yes, sir.
Explain.
So first of all, we revised the previous lecture of regression and correlation.
Yes.
And then we started with the question where, the question, and we found the covariance regression with the model y estimated equal to b0 plus b1 into x plus e.
Yes.
Where b0 is the slope coefficient. B0 is the intercept term, b1 is the slope coefficient, and e is the residual term. Then we saw the graph where there was positive correlation, very high positive correlation.
Yes.
Then we used LM function, and then we used the data table.
Yeah.
That's about
what is that final example I explained? Why I explained the final example?
So you explained that. For forecasting. You told us that in business, what is the risk? The uncertainty is explained by statistics, and you explained the business model that there are various aspects also to that, like inventory cost and all.
Very good.
Thank you, sir.
Simran Ahuja.
Yes, sir.
Do you follow today's class?
Yes, sir.
Module 1, Module 2, Module 3. Which one you like the most?
Sir, Module 3.
Okay. Why?
So, why do I like Module 3?
Yeah.
Sir, because Module 3 is basically a combination of Module 1 and Module 2. So, we learn like the application of correlation and regression in real life. So that is what we'll use in future also.
Correct. You are specializing in agribusiness?
No, sir. General economics.
You are interested to specialize later on PhD?
Sir, yes, sir. Like I'm inclined towards research.
In case if you have such an interest, you have to learn full statistics.
Yes, sir. Right, sir.
Yeah. Explain me your understanding of today's class.
Sure, sir. So today we started with a little from the previous class, our the functions that we did in the previous class,
Yes.
the AB line function, the plot function.
Yes.
And then we moved on to the first question where we computed the B0 and B1 values using
Yes.
the formula that you've given us.
Yes.
Then we calculated the Y estimated line and we plotted the Y estimated line against the X values.
Yes.
Then we found out the error term and the standard error.
Very good.
Then we continued towards the second question that we had to do, and then we used the LM function and the summary function to get all the values together.
Yes. Good.
Then we also...
It's okay, Simran. Very good.
Okay, thank you so much, sir.
Yeah. Sujit Kumar. Where is he? Sujit Kumar.
Yes, sir.
Do you follow the work that I have done?
Yes.
You attended all the module 1, 2, 3? Till last Monday, you were there in the class?
Yes, sir. I was there. Am I audible?
Yeah, it's okay. Okay. Fine. Anybody has any question to ask?
Yes, sir.
Ask me.
Sir, the function, LM function which you told, are we supposed to cram these 2 steps, or there is some logic behind this? Like in these 2 steps, we get just complete answer.
Correct. In LM, complete analysis and its validity will be included. That's all. You will get the entire result of the analysis, which I didn't do in our examples. In the examples, I have computed it in steps. Himani, are you listening?
Sir, I am listening, but I'm not getting.
LM.
Model and summary model. Sorry?
Yeah. In summary model, I will get every answer if I use the model as LM.
It didn't provide any formula what we are supposed to compute.
Nothing. No need of remembering the formula, but the concept of correlation regression you have to follow.
Okay, sir.
Basic idea of learning correlation regression you have to follow. Rahul Giri, you are supposed to ask something?
No, sir, I was just telling her that, like, the LM is a function where, like, the background coding is done by the coders where all these steps are already taken into consideration. What we have to, like, remember is that this function is used to calculate linear regression models, and that is all. So we do not need to follow all those steps. We just need to remember that this function LM takes everything into consideration and is throwing us output, which we check from the summary function.
Right. It includes everything. Completely.
Okay, thank you so much. That was my concern, that it is done behind the code. When the coder has already done that.
Yes. Such is the work that we are going to do in Solver, also in Excel, operation research after statistics. Many computation are tedious, but if you use the package as output ready, that's the reason I say reading and listening the video and attentive for the session, things will be better. Okay, so the today's time is over. Good class, very good class. Keep it up. Bye. Goodbye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.